Hello, class. Let's take a look at GPS 25. So in GPS 25, we're going to look at exponents. All right. And more specifically, we're going to look at some rules of exponents. So the first rule of exponents we're going to learn is called the product rule. Okay. So if you remember from a few GPSs ago, product means to multiply, right? So let's take a look at what the product rule says. Well, one thing we should cover first is that when we look at exponents, right? The x, okay, that's called the base. And then the 3, that's called our exponent. Okay, so for example, if I have y to the 5th power, right? So y, okay, this guy is called our base, and this guy is the exponent. Okay, so if I talk about the base, you know what I'm talking about. If I talk about exponent, you'll know what I'm talking about. All right, let's see how this product rule works. So the product rule says that if I'm multiplying, all right, two terms, I add their exponent. Okay, so if I'm multiplying, I add their exponent. So if we look at 25.2, oh, and one thing you have to remember is that we can only add their exponents if they have the same base. So for example, for this one, we have y to the 5th times y to the 4th, right? Make sure they have the same base. Do they have the same base? Yes, they do, right? This has a base of y, and this one has a base of y. So we can add their powers. So that becomes y to the 5 plus 4, which is equal to y to the 9. Okay? So again, the rule is if they have the same base and they're multiplying, we add their exponents. For the next one, same thing. Check if they have the same base. This has a base of a, this has a base of a, right? So they have the same base. So what do I do if they have the same base? And I'm multiplying, I add their exponents. So that gives us a to the 9 plus 6, which is a to the 15. And that's it. That's all there is to it, really. Let's look at another one. All right, so what happens if we have coefficients in the front, right? Meaning what happens if we have numbers in the front? So if we have numbers in the front, or coefficients in the front, you just gotta multiply the numbers. So you would just say 8 times 7. 8 times 7 is 56. And then it's going to be b to the 2 plus 9, which is b to the 11. Okay, next one, same thing, multiply the numbers first. So that's going to give us a negative 5 times 6 is a negative 30. And then since that's an x and that's an x, we can add their powers. So that's going to give us a x to the 12, right? 3 plus 9 is 12. That's it. All right, so you can pause the video now and try the remainder of the problems on your own and see how many of them you get correct. Right, so you can pause it now, and then I'm going to just continue, and then you can check your answers at the end. So let's look at the next one, 25.8. All right, this one looks a little complicated, but it's really not. So what you want to do is you want to multiply all the numbers. So we have a 6 times 2, and then times negative 3, right? So we're multiplying all of them. So 6 times 2 is 12. 12 times negative 3 is a negative 36. Okay, you use your calculator for that, right? Now you want to combine all of the W's, okay? So, oops. So that's a W, that's a W, that's a W, and a W, right? So now if you look at this W, there's no power for this W, right? So you have to remember, if there's no power here, there's always an imaginary 1, okay? So that W always has an imaginary 1 power. So technically, it would be W, which is 1 plus 4 plus 3, okay? So you do W to the 1 plus 4 plus 3, which is W to the 8. Okay, 1 plus 4 is 5, plus 3 is 8. Now we're going to do the x's. Okay, so actually, maybe I make this a little bigger. Yeah, okay. Now we do the x's, right? So here we have this x, and this x. So it's x to the 9. 9 plus 6 is 15, plus another 8 is 23. That's x to the 23. And then now let's combine the z's, right? So this is z squared, and then z5, and then z2. So it'd be 2 plus 5, 7, plus 2 is 7, 8, 9. So z to the 9. Okay, so you're pretty much just combining you're adding up all the powers that have the same base, right? All right, let's look at the next one. So the next one, same situation, right? Multiply all the numbers. So we would have 2 times negative 4 times 5. 2 times negative 4 is a negative 8, times 5 is a negative 40. And then we're going to put all the the a's together, right? That's a to the 5, and then there's no a in this one, but there's a here. And remember, that's really a to the 1, right? So it's going to be 5 plus 1, which is a to the 6. Right? Now let's look at the next one. We have b, right? So here's b to the 1, and then here's b to the second. And there's no b's in the last one, so it's just going to be 1 plus 2, which is b to the third. Okay? And then the c's, there's a c3 here and a c4 here. So it'll just be 3 plus 4, which is c to the 7. Okay? And that's it. Let's continue. All right, so next thing we're going to talk about is the quotient rule. So remember, if we're multiplying with the same bases, we add their powers, right? Now, if we're dividing with the same bases, we subtract their powers. So in this situation, you see how a to the 5 and a to the third, same base, right? So same base, we just subtract the powers. So it's a to the 5 minus 3, which is going to be a to the second. Okay, we subtract. So let's look at some problems. So if we have a coefficient in the front, right, you just divide the coefficients then. 6 divided by 3 is 2, and then you subtract the powers. Y to the 7 minus 4, y to the third. Okay, next one, we do 12 divided by 3, which is 4, and then we subtract the power of the x's. That's going to be x to the 4 minus 1, which is 3, and then we do y to the 3 minus 2, which is y to the 1. But remember, there's always an imaginary 1 here, so we don't have to write the 1, but remember there's a 1 here. Okay, that's it. All right, so next thing I want to talk about is negative exponents. Okay, so this is kind of important. So negative exponents. Okay, so basically when you have a negative exponent, for example, if you have x to the negative 2 power, all right, you cannot leave exponents negative. So whenever you have a negative exponent, you always have to put a 1 on top. Okay, so that turns into 1 over x squared. Right, it's the same exact thing except with a positive power and a 1 on top. But keep in mind, negative exponents does not make the fraction negative, okay? That's a very common mistake that students always think. They think that when the power is negative, this fraction becomes negative. That is not true. All the negative exponent means is you put a 1 on top, and then you make the power into positive, okay? Like you see here. So if I have x to the negative 5, okay, what's that equal to? Remember, negative exponent just means put a 1 on top, and then make the power positive, all right? All right, so let's just do one more. So let's say I have b to the negative 7. What is that equal to? Remember, negative power, 1 on top, b to the 7. That's it. Okay, you just put a 1 on top. You bring them to the denominator and make the power positive. All right. So if we look at the example from the book, right? The example in the book has a squared divided by a5, right? So what do we have to do? We have to subtract, right? So we have to do a. That's 2 minus 5. What's 2 minus 5? A to the 2 minus 5 is really a to the negative 3, right? So what's a to the negative 3? A to the negative 3 is 1 over a to the third. Okay, let's look at some examples. Okay, so let's look at this one. So same thing, we're going to first divide, right? So can 64 go into 16? No, it can't, right? So one thing you should remember is if we can't divide, if 64 cannot go into 16, what do? We reduce, right? Remember that? So again, if we can't divide, if 64 does not go into 16, then all we do is reduce. So now we reduce. So you think, what goes into 16 and 64? You might think about using 8, right? So how do we reduce? Divide both sides by 8. No, top and bottom by 8, right? That's how we reduce. You think of one number that they can both divide into, okay? Pick one number they can both divide into. So 16 divided by 8 is 2 over, and negative 64 divided by 8 is a negative 8. So what do you notice? You can actually reduce again, can't you, right? So I can now reduce again, reduce by 2 then, right? Okay, so then what would you get if I reduce by 2? So that actually, final answer is actually a negative 1 over 4. Which would have been faster if you initially divided the numerator and denominator by 16, right? But I'm sure a lot of you did not see that at first. That's why I chose 8 and 2. But it would have been faster if you divided the top, the 16 by 16, then you would have gotten the 1 right away. And you divide 64 by 16, and then you would have gotten the 4. Okay? And remember the negative, we can always put the negative on top if you want. Okay, so that's the fraction. We took care of the fraction, the numbers now. Now we do the x's. So that's going to give us x to the 4 minus 2, which is x to the second. And then we do y. Remember, there's an imaginary 1 on the y, right? There's an imaginary 1 on the y, so it's really 1 minus 4. So it's really y to the 1 minus 4. So what's that? Y to the negative 3. Okay? So now what you want to do is change everything into a fraction, okay? That's the easiest way to do simplify these. Change everything into a fraction. So I have negative 1 over 4. I'm going to change x squared into a fraction. So if you remember, I can always write it x squared as x squared over 1. Okay. Now I got to change y to the negative 3 into a fraction. I got to change this guy into a fraction. How do I change y to the negative 3 into a fraction? If you remember, it's you put a 1 on top, right? 1 over y to the third. All right. And then now we just multiply straight across. So when we have fractions, okay, multiplication of fractions, you just multiply straight across. Right? So if I multiply straight across, what do I get? I'm going to get a negative x squared on top, divide by 4, and then y cubed. That's it. Right? When we multiply straight across, it'd be negative 1 times times x squared. Right? Let's make that a little nicer. Yeah, let's do okay. It's negative 1 times x squared times 1. So it's just negative x squared in the numerator. And then we have 4 times 1, which is 4, and then y cubed. So 4y cubed, that's it. And remember, if you have a negative in the bottom, you can always put it on top. That's what I did here too. Okay? Okay. So I'm gonna have to erase this so I can do the other one. Actually, maybe I can just do the other one on the side here. Okay, yeah. So let's keep that here. Let's do the other one here. All right. So again, we're gonna divide the numbers out, right? But can 8 go into 16? No, it can't. So since 8 cannot go into 16, what do? You reduce, right? So what number goes into 18 and 8? Only 2. Okay, so you gotta divide top and bottom by 2. So if I divide top and bottom by 2, I end up with 9 over 4, right? That's reducing, right? So it's reduced. Now I do the a's. That's going to be a to the 7 minus 2, which is 7 minus 2 is 5. Then I do the b's. That's b to the 1 minus 3, right? Because there's an imaginary 1 on the b. So it's 1 minus 3. What's 1 minus 3? Negative 2. Now what do? Change everybody into a fraction. That's 9 over 4. And then that's a5 over 1, right? If you have a whole number as a power, you can just put it over 1. 1 on the bottom, right? And then now change the b to the negative 2 to a fraction. Remember, that is 1 over b squared. Okay, so now what do? Multiply straight across. Okay, multiply straight across. What do you get if I multiply straight across? It's going to be 9a to the 5th divided by 4b squared. And that is our solution. All right? Okay, let's do some more. All right, let's take a look at these. So to do these, pretty much same thing, right? You want to first simplify the numerator. So you're going to do 8y squared times 2y squared. So 8 times 2 is 16. And then since we're multiplying, we add the powers, right? So it'll be 16y to the third. Divide by negative 4y to the fifth. So now 16 divided by negative 4, that divides evenly. That is actually a negative 4. Right? And then y to the 3 minus 5. 3 minus 5 is negative 2. And what do I do now? Change everything into a fraction. So that is equal to negative 4 over 1, right? And then that's 1 over y squared. Now multiply straight across. So what does that give me? Negative 4 over y squared. Okay, that's it. Let's look at the next one. Same thing. You want to multiply 6 times 3. 6 times 3 is 18. And then no x's, so it's just going to be x cubed y to the third, right? Right, there's no x's, so it's going to be x cubed. And then it's y to the second plus 1, right? So 2 plus 1 is going to be 3. That's how I got the 3 for the y. And then 6 times 3 is 18. Okay, divide by negative 15 x y to the fifth. Okay, so what do I do now? 15 does not go into 18, so all I can do is reduce. So let's reduce. What do I reduce by? What number goes into 18 and 15? 3. So I divide top and bottom by 3. So what does that reduce to? That's going to reduce to 6 over negative 5. Okay, but I'll put the negative on top later. And then I do the x's, so that'd be 3 minus 1, right? So that's going to give me a 2, right? 3 minus 1. And then 3 minus 5 is a negative 2. Okay, so now what's that equal to? Change everything to a fraction, so let's rewrite this as negative 6 over 5. That is x squared over 1. And then y to the negative 2 is 1 over y squared. Now multiply straight across, I'm going to get a negative 6x squared. Divide that by 5y squared. And that's it. That's our answer. Okay, let's do some more. All right, so same thing. We're going to do negative 15 times 2, right? Negative 15 times 2. That's going to be negative 30. Oops, that's negative 30. What am I doing? Yeah, so it's going to give us a negative 30, negative 15 times 2, negative 30, and then no x's, so just x to the 7, right? And then we have y to the 6 times y to the 6, so we add the power, that's y to the 12. And then we have z1 times z third, that's z4. Okay, divide that by negative 25 x y fifth z6, which is equal to, now 25 cannot divide 30, so it's reduced, right? But negative is going to give us a positive, okay? So keep in mind our answer is going to be positive, right? And we can reduce by 5. Reduce by 5. So that would give us a 6 over 5. Okay? And again, it's positive because I have a negative dividing by negative, right? Negative divided by negative turns into positive. So that gives us a 6 over 5 after reducing. X to the 6, y to the 12 minus 5 is a y to the 7. And then that's z to the 4 minus 6, which is negative 2. It's a negative 2. Now change everything into a fraction. That gives us 6 over 5. Change x to the 6 into a fraction, x to the 6 over 1. Change y to the 7 into a fraction, y to the 7 over 1. And then change z to the negative 2 over into a fraction, that's 1 over z squared, which is equal to, multiply straight across, 6x 6, y 7, divide by 5z squared. Okay, that's it. Let's look at the next one. So again, multiply 4 times negative 9. That's going to give me negative 36. And then I'm going to do A1 times A12. That's A13. And then B1 times B1. That's going to be, we add, right? B1 times B1 is 1 plus 1. So it's B to the second. Divide by, that's going to be negative 30 times 2, which is going to be a negative 60. And then it's going to give us a to the 6 plus 4, which is a to the 10. And then b to the 4 plus 7, which is 11. Okay, now that's equal to, now negative again turns into a positive, right? So we're going to get a positive fraction. And how can I reduce this? I can reduce by, well, initially you see 6, right? So let's reduce by 6 first. Okay, so if I reduce by 6, what do I get? I'm going to get a 6 over 10. But what do you know about 6 over 10? I can reduce again, can't I? Yeah, I can reduce again by 2. Okay, so actually our fraction actually simplifies into 3 Let's write that. So our fraction simplifies into 3 over 5. Okay, positive, right? Because negative turns into positive. Now do the a's. That's going to be a to the 13 minus 10. So that's a to the third. And then that's b to the 2 minus 11, which is b to the 9. Negative 9, sorry. Right? That's 2 minus 11, so negative 9. Change everything into a fraction. That's 3 over 5. A to the third over 1. And then that's going to be 1 over b to the 9. Right? Multiply straight across. So what's the answer? 3a cubed divided by 5b9. There you go. And okay. So now let's talk about the zero exponent rule. So basically the zero exponent rule just means that anything to the zero power is always equal to 1. Or you think of it as canceling out, okay? So here you would get a to the 2 minus 2, right? So 2 minus 2 is a to the 0. A to the 0 is 1. All right? Or you can think of them as canceling out. So let's look at an example. Okay, so here we have x to the 4 divided by x to the 4, right? So what happens? 4 minus 4. So you would get x to the 0. 4 minus 4, x is 0. And then you would get y to the 1 minus 4. 1 minus 4 is negative 3. Okay, and then what happens to x is 0? That turns into 1, but think of that as canceling, so that cancels out. So what's left? Y to the negative 1/3. So we can't leave it that way, right? You can't leave negative powers. So just change it into 1 over y to the third. And that's it. So similar situation here. We have 24 divided by 18. Can it divide evenly? Nope, it can't. So we got to reduce. What goes into 24 and 18? 6, right? So we divide top and bottom by 6 by reducing. So we're going to get 4 over 3. Okay. A to the 5 minus 7, which is a negative 2. And then we do the b's, right? So the b is going to be 1 minus 5, right? Remember the power here is 1. 1 minus 5 is negative 4. And the c, that's c to 0, so cancel that out, right? C to 0 just cancels out. So then we're left with this. Now change everything into fractions. So that is really 4 over 3, and then 1 over a squared, and then 1 over b to the 4. What's the final answer? 4 over 3a squared b4. Okay, and that's it. And there's no c in the answer, right? Because what happened to the c? C to the 0 cancels. Okay, so there's no c. And that's it. Okay, yep. So if you got lost anywhere, again, pause the video, replay it again. If you have any questions, you can post on the discussion forum. Okay, so see you next time.